Okay, so let's start our discussion for today. So our first topic in our list is Introduction to Open RAN. The topics are what is RAN, RAN solution, RAN and OSI layer, what is 5G, RAN architecture, what is Open RAN, the GPP hardware and open systems. So I will show you some websites or resources where you can find this GPP hardware and open systems, Open RAN ecosystem, and deployments and trials of Open RAN in different countries. And to summarize is the key learning points. So let's start with what is RAN. Okay, so what is RAN? I'm sure everybody knows what is a cell site. No? So in the video that you're seeing right now is an example of a cell site. Okay, so this is a cell site. So we refer it as RAN. So radio access network. So when we talk about RAN, it means radio access network. So people can make calls, send text messages, participate in video calls, connect to the internet, watch videos on YouTube, and explore social media platforms like Facebook, Instagram, Twitter, because of the infrastructure that supports telecommunications like this. The infrastructure gives us mobile coverage or signal level. So this is the one that we see in our mobile phone, the signal bars. So the more bars you have in your mobile phone, so the better the signal level. So this can be found, these infrastructures can be found practically anywhere to provide services to small villages or a community or a town like this, or even a whole nation on a significant scale or a massive number of radio access network. So what you're seeing now is a target coverage area. So this a video capture coming from a drone that was flown above the antenna system. So you can see the different target areas of this radio access network. Okay. So this is a simple example of a radio access network. So those radio access network provides us a mobile network coverage. Okay. So this is a typical example or an illustration of a mobile network coverage. So the one that you're looking at right now is not, I repeat, not an accurate picture of the coverage offered by mobile operator. Rather, it is a portion of that coverage. So the information comes from the tests that users of the NPerf application have conducted on themselves. So these tests are carried out in real world in the location where they will actually be used. So if you own a smartphone and want to participate in the test, the NPerf app can be easily downloaded onto your device for free. So you don't have to pay for it. So the more available information, the more accurate and detailed maps will be. So on the maps, you can see the outcomes of all the tests. The use of filtering rules comes before the computation of performance for publications. So they collect the signal levels from the subscribers who want to share their data through their app on this website, which goes by the name NPerf. However, if you look at this sample map, you can see the distribution, okay, of subscribers as well as the technology that they are utilizing. So there are locations that are served by 2G, okay, 3G, 4G, and even 5G. Now that you have seen this application, let's look at this website and investigate what it offers. So I'll give you this website. Oops, sorry. I'll give you the website of this NPerf so you can also browse it. So in your browser, you can type it in or just click the link. Okay, so ito yung link natin for the NPerf. So when you look at the NPerf, ganitong itsura niyan. So whenever we have this kind of activity, for example, I give you a link, so you just try to click it. Don't worry, it's not it's not it's not going to something suspicious, no. So yeah, so ito yung nperf. So you can check this nperf, so you can browse it. So pagpunta niya sa nperf, I would advise you to save the browsers. No? So ano bang meron dito, no, sa nperf na to? So you can select a carrier, like for example here in the Philippines. Actually, there's a lot of countries na available dito. Of course, we'll be focusing on the Philippines. Okay, so and then you just select some operators. So it's either let's try Globe. So you can see the sample technology that the subscribers are using. So as I mentioned, this is not the whole representation of the operator's coverage. This is just a sample. So the more participants or subscribers that joined in this app, the more samples that they have. So makikita nyo may mga areas na wala silang sample kasi walang mga subscribers who have joined in their app. Kaya yan. So pero it's a good indicator to check if there are already for example 5G signal in the area. So in the NCR there's a lot of areas covered already by 5G. Okay? And as you can see, some of the samples here are mostly located sa mga roads, no? Nasa road sila. And some of them are probably located sa loob ng mga bahay. As I read here, ang nperf is using around 50 meter by 50 meter resolution. So when we talk about resolution, meaning within 50 meters by 50 meter square, so nandun yung subscriber. So it is not that accurate, especially kapag ka nasa mall ka. 50 meter by 50 meter is big. And then for data, they are using 200 meter by 200 meter resolution. So that's becomes bigger. So kapag ka nasa isang barangay ka lang, 200 meter by 200 meter is actually big, you know. So mahirapan tayong hanapin kung sino yung kung sino yung gumagamit na yan. Pero it's a good estimation and indicator that in a certain area kung meron na silang 5G or wala. Okay. Okay. So there is another useful tool available and some of you may be already familiar with. It's called the speed test by Ookla. Okay, so this is a speed test by Ookla. Once the app is installed, it will do a test automatically, or we need to run test manual. It will run automatically, but it will ask you if you want to participate in the contribution. But if you don't want, it's okay. You can still see the signal levels or the technologies submitted by other subscribers. Okay, so this is a speed test. So normally what we do in the network, we are trying to check how fast is our connection. No? So let's try the connection. So this is speed test, speedtest.net. So you try, right now I'm connected to a Wi-Fi networks. Kaya minsan mabilis yan. No? But you can take a look then sa inyong mga mobile. So mobile phone. So pag nakita mas mabilis siya, mas maganda. Normally kapag kayo ay nakakonect sa 5G, it is faster. Okay. Okay. So what I want you to check also in this website. Okay, so let's save it first. Okay, so browser, sa bookmark natin. So andito na yung ating folder. And then we will just save it in our bookmark. Okay, yan. So para lahat ng mga ano natin, ng mga mga browsers or mga websites na ibibigay sa inyo are saved already. Okay. Okay. How much data, sir, is being uploaded para sa mga limited ang data plans and budget? Actually, it's ano naman, for example, the speed is being measured in bits per second. And then normally, what we have is in our plan is in the gigabyte. So hindi siya ganong hindi ka mauubusan ng data. Yan. Okay. So what I want you to go here is in the Ookla 5G map. Okay, so when you click the Ookla 5G map, so it's a different view naman compared with NPerf. So when you look at the Ookla 5G map, although this is not real time, right? So it depends on it's a discretion, in the discretion of the operators if they want to submit their status of 5G deployments, like for example, commercial availability. So when you say commercial availability, the 5G network is present and devices are available for consumers to purchase. And then if you look at the limited availability, the 5G network is present, but devices are limited to selected consumers. Okay, and then there's a pre-release as well, where the hardware is in place. So naka-install na siya siguro, but currently that in testing or not yet accessible to consumers. So ang terminology natin dyan is not yet on air. Okay, so hindi pa siya ready for commercial purposes. So you can see the number of 5G submitted by operators, kung gaano na karami. So dito sa Pilipinas, actually this one is probably not so true, no. What I know is there's more than 100 already deployed for all operators here in the Philippines. Okay, so when you zoom it in, okay, so makita mo yung mga distribution of 5G locations dito sa Pilipinas. The reason why I said it's not so accurate, because here in my place in Binyan City, I already have 5G signal, but in this map, they're showing nothing, nothing yet. Even the pre-release, they don't have. But right now, I'm covered already by 5G. Okay, so this is an example of the locations of the 5G map. So you can use it to assess in an area. So for example, you're going to have a vacation and then you would like to check if there is a 5G signal or LTE signal in that area. You can use all these apps to initially assess the coverage status. Okay. All right. So, sir, what is the difference of this? Because when you mentioned that it is not so accurate, what do you mean by that? No, yung sabi ko nga, kasi nga this is only coming from different subscribers who participated. But in the radio network design perspective, what we are trying to do is to have a simulation. We are creating simulation to somewhat accurately predict the status of the coverage in that area. So I'll show you one sample like this. I created one sample here. So this is a tool that we use in the radio network planning and optimization team. So this work in RF, mostly nakikita nyo to sa mga operators like Globe Telecom, Smart or Dito, and mga vendors like Huawei, ZTE, Nokia, Ericsson. Okay, so these are engineers that handling the planning and the optimization of the network. So basically, they are armed with a tool like this, what I'm showing to you. This is a simulation tool. Okay, so let me just show you what this tool can do. So basically, you have a mapping software or GIS, and then you can put or plan where the base stations or the cell sites will be built. Okay, so meron tayong mga locations ng mga cell sites dyan. And then for us to predict gaano kalayo, because sometimes if one person or even an engineer is not engaged in this kind of work, they are always curious how far would be the coverage of one cell site, sir. Yan. Okay? So most of the time, yan yung mga na-encounter naming mga questions. Gaano po kalayo ang nararating ng isang cell site? So in the perspective of RF engineer, it's really a hard question. Okay? We always answer it depends. Why it depends? It depends on the, like for example here, it depends on the power. It depends on what signal level you are talking about. It depends on the radio equipment. It depends on the specifications, which we will study later. From the antenna, going to the cable, and going to the height, no, of the antenna where it is installed. Okay, like for example, these base stations right now are having 50-meter antenna. Okay. Ayan. So this software includes the map. So the map is composed of first is the clutter type, as mentioned by Sir Eugene. So it is using a clutter data. But right now the clutter data it is using it's not so accurate, no. So when you look at here in Cavite area, most of the clutters are in vegetation or forest, no, or trees, and some of them already in an urban area or suburban area, and some of them are classified as vegetation area. Like for example here, there are already people here, but it is considered as still a vegetation area, but the road is already considered as road clutter. Okay, so clutter meaning the classification ng mga areas, no. So kung yung mga areas is like for example here is a suburban area, okay, so ganito na kina-classify yan. So para maturuan yung software how to do the simulation and calculation. Okay, so you will have this clutter map. So different layers. You have the clutter map. You have this terrain map. Okay, so if there is a hill or mountain or a lake, yan, or a river, yan, or roads, yan. So meron tayong mga terrain maps, no. So in the perspective ng radio access network, so that's why if you are engaged in a radio network planning activities, as I mentioned in my previous webinars, you can predict, no, you can have somewhat what we call the crystal ball, where you can predict where the signal will go, you know, where the signal will become strong, where the signal will become weak. So what we do here, let me just clear the map now. Okay, so you can just see the Google Earth map. So this is simple simulation tool. So just to illustrate to you how signal levels are being generated. Okay, so this how a sample signal level looks like in the simulations perspective. So what we are looking at is a colored map, no. So pag tinignan natin yung legend niyan, okay, so when we take a look at the legend, so this is the legend. So makita nyo, yung dark blue is around -70 dBm until papunta tayo dito sa value na to, sa kulay na yan. So itong mga kulay na to, these are -120 dBm. So to make it easier, kapag tumataas yung signal level at a negative value, ibig sabihin mas humihina yung signal mo. So ito yung ibig sabihin sa mobile coverage. So if you are a subscriber located, like for example, located at 3.5 kilometers from a known cell site, your signal level could be at -120 dBm. So probably wala kang signal or merong 1 bar signal na nawawala on and off yung signal level mo. So that's what what I'm trying to say na napipredict natin kung hanggang saan yung ating mobile coverage. So this is just an example of a 2G or a GSM mobile coverage. So in terms of simulation, the radio network designer or an RF engineer will be able to simulate or do simulation with different technologies like GSM, UMTS, LTE, and 5G. So this is the simulation map. So we can decide and plan where is the best location for a cell site. Okay. Okay. So makita nyo itong mga roads are completely covered kasi mas mababa ang ating mga propagation loss kasi open space siya. And then when it comes to some clutters na medyo matataas ang losses like yung mga villages or urban areas, we will have lower signal level. Okay, so I hope it gives you an insight about the mobile coverage. So it's much different sa actual na ganito. So hindi nyo siya nakikita ng buo. So ito kasi is based on the actual measurement that is submitted to the server ng NPerf. And when it comes to planning, ito naman nakikita natin. Okay. So kumbaga ang nakita natin sa NPerf is itong mga roads na to, pero in reality there is a signal level propagated here in this area. Okay. So like for example, when we in this area, so kahit na ito ay merong signal level sa NPerf, okay, so it doesn't mean na wala ring signal level dito, pero meron yan signal level. Hindi lang pumupunta yung mga tao dito sa gubat, no? Tell kung what is the reason for them to go here. Yan. Okay. Ayan. So I hope you got some idea how a mobile coverage looks like, in the perspective of a radio network designer and in the perspective of a subscriber. Okay. Okay. So the location and the distribution of radio access network sites as well as the technologies involved determine the mobile network coverage. Okay. So how do we get signal coverage and how do we get connected sa core network? Because we are accessing services to the core network. So basically, we have an architecture of wireless telecommunication system. So it comprises of a user terminal, okay, also known as the user equipment. So for 3G, 4G, and 5G. So we call our terminals as user equipment. And for 2G devices only, we call it the mobile station. Okay, so if you are in the telecom world, kapag pinag-uusapan natin yan, kapag humihingi tayo nanghihiram tayo ng telepono, it's either a UE, can I borrow your UE, meaning yung kanyang telepono is capable for 3G, capable sa 3G, 4G, or 5G. But if it's only capable of 2G services, we call it the mobile station. Okay. And these user terminals are connected via RF or radio frequency sa ating RAN, Radio Access Network. Okay, ito yung mga cell site kanina na pinakita ko kanina, no? So we have this invisible electromagnetic energy, na nagko-connect sa user terminals at radio access network. So there is a term, na laging sinasabi ng mga non-ECE, may radiation, there's a radiation coming from the radio access network. Actually, it's correct, because radiation is a term that we use to describe the transfer of energy from one place to another through space or vacuum, that we don't need any medium to transfer. Like for example, kasi yung sound waves, we need a medium, right? We need air, or we need water. So, but for the electromagnetic energy, we actually don't need any medium. It can travel through space. And that mechanism is called radiation. Okay, so tama yun. Kapag may mga wireless communication devices tayo, there is a radiation. But the radiation that itself per se is not the radiation. Yung para kasi pag sinabi mo radiation, pagka natinama ka, kalbo ka agad. No, so that is only the transfer of energy from one place to another through vacuum. Okay. So this is connected by the radio access network, and the radio access network, okay, is connected to our core network through a backhaul network. So the backhaul network could be a microwave, a fiber optic, or via satellite. Ayan. So the negative perception yan, sabi ni Sir Eugene. Yeah, that's correct. So that's why whenever we hear some radiation issue or radiation concern, so it's our task as an ECE is to educate those people, but educate them in a soft manner, because sometimes people get angry, no, when you try to teach them about the radiation. Yeah, there's a lot of myth actually. There's nakakabaog, there's yung pananim nila is not growing, the trees are dying. Yeah, so there's a lot of myth about that. Birds are falling down. Whales are dying. Yeah, so yeah, cancer. Yeah, so there's a lot of concerns about this kind of technology. Okay, so whenever we want to access some services, so we need to get it in the core network. So the core network probably connects us to other core network or other servers or through the internet. So for us to be able to access those services. So what we are trying to focus right now is the radio access network. Okay, so this is the main focus of our study for today. So what is actually a radio access network? So radio access network is the section of a cellular network that is closest to the subscribers or customers. It is widely spread and huge in number to enable the seamless coverage and mobility. Okay, so it's almost around us. Okay, so the location is widely distributed. You can see it everywhere actually. City, village, highway, rural, hills, beach, malls, and office. Probably after this session, you will be your third eye. Your radio access network third eye will open. So what do I mean by this, no? So when you go out and then pag lumabas kayo, no, mapapatingala kayo lagi, and then you will be more aware. Ito pala yung cell site, no? Ito pala yung 2G. 5G to. Ito pala LTE, no? So your radio access network third eye will open after this session. Okay? So sometimes, most of the time, ang ating radio access network have output power of either 20 watts, as I shown you in the simulation. No? So basically, we have a nominal output power for the radio. So the output power for the radio is sometimes 20 watts, 40 watts, no? 80 watts. And then, minsan na lang, syempre, kung gumagamit tayo ng tinatawag nating massive MIMO, where the electromagnetic energy is concentrated in a single beam, mamaya pag-usapan natin yan. So, the power become higher. So, because of this, no, yung low power characteristic ng isang radio access network, the coverage is not quite as extensive as the broadcasting station. So, yung broadcasting station, which sends out approximately 50,000 watts of power. So, narinig ko yan nung I'm not sure if there's somebody here in the broadcasting industry about the output power ng ating mga broadcast station like television or FM or AM. Kapag nanonood ako dati sa Channel 2, pagka magbubukas siya, no? ABS-CBN now transmitting at 50,000 watts. Yan, kaya ako siya ginamit, no? Yun yung last thing na I remember whenever I watch yung unang-unang palabas sa Channel 2 dati. So because of the low power characteristics and limited coverage area, no, so we need to build thousands of RAN elements in order to achieve yung seamless coverage and mobility across the country. So ano yung seamless coverage and mobility? So kinakailangan natin kasi ma-estimate, di ba? Yung ating coverage as I shown in the previous simulation like this. Okay? So if our radio access network are separated too far from each other, there will be a coverage gap. As you can see probably here. There is a coverage gap here in this area. You see? In this red portion. Because they are separated too far from each other. Yan. So around 4.9 or 5 kilometers. So we already experience a coverage gap between these two. So in this reason, we need to build a lot of radio access network elements in the entire country to have a seamless coverage. So that's why you can see radio access network almost everywhere. You can see it everywhere. Paglabas nyo pa lang, may makikita na kayong radio access network or cell site. Okay? Ayan. So thousands of RAN elements create seamless coverage and mobility. So that's why I'm saying, no, makikita niyo siya kahit saan. It's all around you and encompasses you completely. You can find it by the roadside, okay, in the province, on a mountain. Yan, pagpunta kayo ng Baguio, ang dami makikita dyan. Dun sa pagpunta kayo ng Baguio, di ba, meron dalawang electric fan doon sa taas. Those are troposcatters. When you go to Mount Santo Tomas, meron kayong dalawang antena. So troposcatters yun. So they are transmitting. Dati, no? And I'm not sure if still active. So maraming troposcatters kasi meron dito sa Tagaytay, meron sa Cebu, okay? And then meron dyan sa Baguio City. So previously used yata sa mga military applications. Yun yung nagka-transmit ka ng electromagnetic energy papunta sa troposphere. Tapos magbe-bend yun papunta doon sa kabila. Yan. So you can find it on the beach. Yan, pagpunta kayo ng Boracay, so babangka-bangka kayo, makita niyo meron doon isang hill. Andun yung dalawang cell site, no, ng dalawang operator. And also you can find it in your favorite shopping centers, sa mga malls. Ito mga nakikita niyo bilog sa taas or sa ceiling ng mga malls. These are what we call the IBS or in-building solutions. So we call it sometimes picosite, small cells, okay? But definitely they still under the radio access network category. So it just they just have a difference in the coverage type. So these are intended for IBS or in-building solutions or in-building applications, indoor applications. Okay? So the radio access network or the mobile communications also evolved, no? Evolved in time. So in our lifetime, I think we witness 5 mobile. So if we are lucky enough, if we will live longer, probably we could experience 6 or 7 or 8 if there will be next Gs, no? But currently we have witnessed 5 mobile generations developed in 40 years. So the first generation of mobile communication was the analog. So you will hear the words AMPS, okay? The advanced mobile phone system developed in North America, NMT, the Nordic mobile telephony, developed by government controlled public telephone network operators. And we have the TACS, the Total Access Communication System used in the United Kingdom. So the first generation mobile communication technologies has limited voice services and introduced mobile telephony for the first time. Okay. So I'm not sure who are among you, no, ang nasa 1G. Ako, wala pa ako dito sa 1G. Next is the second G. The second generation of mobile communications introduced the digital transmissions in the 1990s. Digital transmissions enables 2G mobile data services as well. Like for example, the GPRS, the General Packet Radio Services, and the EDGE, or the Enhanced Data Rate for GSM evolution. When we talk about GSM means the Global System for Mobile Communication. So this is founded by numerous European countries. And there are also contemporary technologies like the D-amps, the digital amps, so this digital version ng amps dito, and the PDC, the Personal Digital Cellular, developed in Japan. So this is a CDMA-based IS-95. So ito yung mga earliest second generation technologies. Nung inintroduce ang GSM sa Pilipinas, the Philippines became the text capital of the world. No? So almost 100 million SMS per day sa Pilipinas lang. So ganun naging kaboom yung yung 2G sa Pilipinas that time. And the GSM spread beyond Europe and dominated the second generation technologies. Okay, so ito yung mga sample ng telepono. Baka meron pa kayo nito, 3310 or 3315 yata, no? Si Space Bomb. Sikat na sikat yan. Okay. Early 2000s brought the 3G. So the 3G mobile broadband and fast wireless internet. So you will hear the words HSPA, the high-speed packet access. 3G allowed the data connection to the internet. Okay, so prior mobile communication technologies used paired spectrum. So dalawa yung spectrum na ginagamit natin. So FDD, merong frequency for the uplink, merong frequency for the downlink. But for the first time in this technology, we use the unpaired technology, the TDD, the time division duplex. That's why we have this TD-SCDMA technology coming from China last time. And then LTE followed HSPA with improved data rates and efficiency. Now it's using a different kinds of multiplexing, the OFDM, the orthogonal frequency division multiplexing. Which provides wider bandwidth. Mas lumaki yung bandwidth ito. And multi-antenna technologies. Just to give an example, for 2G, the minimum bandwidth is 200 kilohertz. For 3G becomes 5 megahertz. And then for 4G goes to 20 megahertz. And then after ng 20 megahertz, there's an improvement like what we call the carrier aggregation. So you can add more carriers from different frequency to have a wider bandwidth for the transmission. Okay. So LTE also allows yung FDD and TDD operation in one radio access technology. And practically all mobile network providers is suited to have a paired and unpaired spectrum. Okay. And then later on, nagkaroon ng expanded version yung LTE which is using the unlicensed band. So meron na tayong natawag na LAA, no, license assisted access. So this is a sample of a variant ng carrier aggregation in which yung isang frequency mo is licensed. Ito yung binabayaran ng mga operators NTC sa kanilang spectrum users fee. And then you can aggregate it with a Wi-Fi frequency, like for example 2.4 or 5 gigahertz. But most of them are using 5 gigahertz. Mas malaki yung bandwidth doon. Okay? So that is the LAA technology. And now we are very fortunate to witness the 5G era, no? Especially here in the Philippines. So the Philippines is hindi yan nagpapahuli, no, sa technology pagdating sa wireless. 5G discussions actually began in 2012. So for my case, when I was working in Ericsson, they sent me sa Thailand para mag-aral ng 5G around 2017. No? 2017 pa lang, nandun na ako sa Thailand where we are learning about 5G. So kapag napunta kayo sa mga vendors like that, like Ericsson, Nokia, or Huawei, you will have that opportunity to be the frontliner. Ito yung typical na frontliner, no? So ito yung mga frontliner ng telecom. So when we say frontliner, so kapag may mga bagong technologies na paparating, you will be ahead of the pack. No? Nandun ka agad. Nag-aaral ka agad. Probably 2 to 3 years ahead sa pag-aaral. Okay? So the 5G is the future of mobile communication. So aside from the mobile phones, there is a diverse opportunities with 5G, which is mamaya pag-uusapan natin. And we have a different run names sa ating mga technologies. Like for example, in 2G, the cell site, we call it the BTS. It's not the BTS na nagsasayaw, no? Yung mga singkit yung mata. It's a base transceiver station. Okay. And we call the RAN as Jaran. Okay. So meron kaming biruan sa terahertz, no? Nung bigla lumabas yan, sabi niya, Jaran. Okay. So GSM Edge Radio Access Network. So that you can remember it, no? So whenever you see a BTS, it's Jaran. So they are always surprising you, like Jaran. Okay. So GSM Edge Radio Access Network. And for the 3G, we call it the Node B. Okay, Node B. And it is called UTRAN. Okay, so UTRAN means UMTS terrestrial radio access network. And then we talk about UMTS, it means Universal Mobile Telecommunication System. Okay, so node B ang tawag natin sa cell site. For 4G RAN, we call it the E-node B. It is also called EUTRAN, or Evolved UMTS Terrestrial Radio Access Network. Okay, for 5G, we call it NG-RAN, or the Next Generation Radio Access Network. So the RAN has its own name, iba-iba yung pangalan niya for every generation, but all have same working principles. So yung mga connections, mobile architecture is almost the same, but some variations. Mamaya makikita niyo siya. No? Okay, so ito yung different names ng bawat radio access network belonging to different generations. Okay, now let's go to the RAN solutions. Okay, let's go to the RAN solutions. So when we say RAN solutions, ito yung mga typical implementations of RAN. Okay, so in this section, we will discuss about the RAN components. Okay, RAN components. So remember, we have these elements in the wireless telecommunication system. We have the core network. Okay, and in the core network, in this example, we will use 4G and 5G core network. And then this core network is connected via backhaul to the BBU, okay, the baseband unit. And there's a baseband unit connected to the RRU by a front haul system. And this BBU RRU plus antenna system, if you would add, is a radio access network. Okay, so ito yung pinaka architecture natin. So when you look at the components of that physically, in the physical structure, this is how it looks like. Typically, we need to have a tower structure. So to elevate yung ating antenna system. As you can see in our previous simulation, typical in an urban area, we will have around 15 to 20 meters yung antenna height natin. And then for suburban areas, we'll have 30 meters. And then for rural areas, we can go up to 40 to 50 meters. And then sometimes, dun sa mga remote places na kinakailangan we need to maximize the coverage, we tend to use around 60 meters of tower height, antenna height, para mas malayo yung marating ng coverage natin to maximize yung ating mga infrastructures. So we need this in tower infrastructure. And kagandahan dito, we are not the one. ECEs are not the one responsible for the tower structure. It's the civil engineers. Okay, so the only data that the civil engineers need from us is the antenna height. Okay, so what antenna height would you design for this type of cell site? Okay, so in this tower structure, we install the panel antennas, so you can see it in the typical radio access network. So you will see this vertical, yung mga rectangular antenna types. Normally it's color white or grayish white. Okay, sometimes it measures around between 0.6 to 2 meters. No, it depends on the frequency. So the bigger the antenna, the lower the frequency. So it's a physics of the antenna design. So panel antenna. So there is a high band antenna, so it could be frequency dependent, or sometimes there are antennas that are multi-bands. So in one antenna, you can use it for different frequencies. So it depends on the specifications. But in this example, I'm showing a single band antenna so that you can visualize that antennas can be used for high bands and for low bands in a separate physical form. So there is this 900, you can see the 900 megahertz is bigger than the 1800 megahertz. Okay. And after that, you will have the remote radio unit, or the RRU. So this is the current approach in deploying our radio access network, RRU. So RRU is also frequency specific. So when we say frequency specific, there are certain frequencies that the RRU is operating. Like for example, this B3, this is operating at 1800 megahertz. And there is an RRU that is operating at B8 or band 8, which means operating at 900 megahertz. So the RRU, the antenna, is connected via copper cable, which is what we call the jumper cables or the feeder cables. Okay, so meron tayong kable, connect yan. So for us, the electromagnetic energy coming from the remote unit will be propagated through the antenna system. And then this RRU, okay, is connected in what we call the CPRI. So Common Public Radio Interface. This is a fiber optic cable, okay, but this is a proprietary interface coming from, like for example, the NEC, Nokia, and Ericsson, and Huawei. So this is proprietary and connected to the baseband unit, so in which the baseband processing is being done. And the baseband unit is commonly installed in an outdoor cabinet or inside a cabin. So there is a container ban na makikita nyo lagi, katabi ng tower. So in the outdoor cabinet or the cabin, nandiyan yung power supply, battery, ventilation, and the transmission system for the backhaul connection. Remember this backhaul connection? So whenever you see yung plato, yung bilog sa cell site, those are microwave antennas. So basically for our backhaul system, for transmission, going to the core network. So when we say going to the core network, it's not directly, sometimes it's not directly going to core network. It sometimes go or connected from one cell site to another cell site. So that meron tayong natawag na hubs. Hub 1, Hub 2, papunta ng core network. Okay, so bihira yung yung mga sites na direkta agad nasa core network. Unless nasa malapit siya sa core network. Okay? Alin po dyan ang need ng radio station license? This one, the remote radio unit, Daniel. Because this one is the one that is operating or radiating or emanating yung mga radio frequencies. Okay, ito. Remote radio unit. So dito rin nakikita yung mga frequencies. Ito kasi hindi naman to frequency dependent. This one is frequency dependent. So this one needs your radio station license. Okay, so the RRU looks like this in the installation. So ganito mga itsura niyan. Typical yung mga RRUs natin malapit na sa mga antenna. Okay. Microwave antennas rin. Yeah, correct, Jimboy. Yung mga microwave antennas natin. Kasi meron din yung radio part. Yeah, thank you, Sir Jimboy. Yeah. Okay, so this is the typical setup ng mga RRUs. So makita niyo na malapit yan sa ating antennas. Okay, so ito yung mga RRUs ng mga existing vendors. I think this one is coming from ZTE. And when we talk about the CPRI, so CPRI is a common public radio interface used to transmit and receive data between the RRU and the BBU, baseband unit. Okay, so it's a standardized protocol communication between the BBU and RRH or RRU developed jointly by major RRU vendors. So it's a proprietary, no? So meron silang sariling protocol per vendor. Kaya yung CPRI, you cannot interchange it. For example, you get a CPRI from Ericsson and then you will use it to the equipment of ZTE. It's not possible because there is a proprietary protocol used and designed by the following vendors like Ericsson, Huawei, NEC, and Nokia. So they are the ones who develop these specifications of CPRI. Now, when we talk about 5G, there is an upgraded version of CPRI. We call it the eCPRI, enhanced or evolved CPRI. Okay. Next is the baseband unit. So ganito yung itsura ng baseband unit. Typical, ang baseband unit is located below the tower. So when we say baseband, it refers to the original frequency range, no, ng transmission signal before it is modulated. Okay, so baseband can also refer to the type of transmission which digital or analog data is sent over a non-multiplex channel. So the equipment that is handling this is the baseband unit. So it is responsible for processing the baseband signals and is placed in the equipment room and connected with RRU via optical fiber. Okay? So dito rin sa baseband unit, when you want to activate GSM, UMTS, LTE, or 5G, you can activate here. And the radio unit, if the radio unit is capable of that certain frequency, there is mga radio units kasi no, na tinatawag nating SDR, software defined radio, na they are not very technology specific, only frequency. But if you activate the technology in the baseband, okay, and your radio unit is capable also for that kind of technology, like for example GSM, UMTS, LTE, you don't need to change anything sa iyong remote radio unit. You can just activate it. Okay? And then yung frequency is as is. Ayan. So ito yung ating mga samples ng RAN components. Okay? So I hope you get familiar with it. So whenever you see a cell site, when you go out after this session, so you will see the antennas, you will see the microwave. Sometimes walang microwave, ibig sabihin naka-fiber yon, naka-fiber optic yon. And then when you see some a big dish, satellite dish, minsan yun, ibig sabihin na naka-ano siya, naka-VSAT siya, no? Very small aperture, nakapunta ng satellite. Okay. So next, we'll go to the RAN and OSI layer. Okay, in the RAN and OSI layer. So when we look at the RAN, radio access network, okay, so this is a typical radio access network. No? And then you look at the RAN equipment, particularly the radio unit and the baseband unit, and then we map it sa OSI layer. Okay, so you will see, just a reminder na yung OSI layer. So OSI means Open Systems Interconnection, or OSI. So there is 7 layers. So this is a model, a set of concepts that describe and standardize how the computer or telecommunication system communications, no, to each other. So meron siyang protocol na sinusunod. So regardless of how it is built or what technology it uses. So in some review centers or in some lectures that you previously attended about the OSI, so there is a mnemonics that being used, right? So OSI, so you would like to memorize the different layers in this correct order: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. So there is a mnemonics. All people seem to need data processing. Yeah, so some of you have a Tagalized version of the OSI model mnemonics, no? In Filipinos, whenever I teach this in abroad, instead of all people seem to need data processing to remember this sequence, I normally say, ang pulis sa tulay na dapa. Ang pulis sa tulay na dapa. Yeah, so that's the Filipino version of all people seem to need data processing, no? Yeah, so sabi nga ni Rhea, no? In Tagalog, ang pulis sa tulay na dapa. Yeah. When you deliver it abroad, you pronounce it, ang pulis sa tulay na dapa. Okay? Can you try it? Okay. Never mind, no? Ang pulis sa tulay na dapa. Yeah. Kasi lang tayo. Okay? All right. So let's take a glimpse. Now, we will not talk about the OSI layer. No, let's take a glimpse. No, let's take a glimpse about the OSI layer and then the mapping. Because when you map the layers of the remote radio unit and the baseband unit, when you map it to the OSI layer, the network layer, the data link layer, and the physical layer is there. No, pero itong mga to, application, presentation, session, and transport is not there. So the application layer, sometimes it's in the user equipment sa telepono nyo, and then sa server applications. Okay, so these are the different functions ng ating OSI layer. So we have the applications and then the different functions and then some examples. Like for example, you want to connect to a browser using the HTTP, hypertext transfer protocol, or the file transfer protocol. You want to download something from a server, or you want to send an email. So you will have a simple mail transport protocol, DNS, and SSH. Okay, so in the presentation layer, so this is the data representation and encryption. So the examples here are the ASCII, the JPEG, HTML, and the doc. Session layer, so for inter-host communication. So it's for managing communication sessions. Examples of this is the RPC, NetBIOS, the application program interface, and the WinSock. Transport is a segment diagram, so datagram. So it's an end-to-end connection and reliability. So we can use the TCP, the UDP, SCTP, SSL, and TLS. Now for the cases ng network layer, data link layer, and the physical layer. So we will have an equivalent protocol in the radio access network. Although, for example, in the network layer, you will have this IPv4, IPv6, IPsec, router, and the L3 switch. In the RAN, there is an RRC, the radio resource control. Okay, RRC. Data link layer, equivalent layer is protocol is the PDCP, the Packet Data Convergence Protocol, the radio link control, and the medium access control. Physical layer, where we have a transmission and reception of raw bit streams. We have this air interface. And so later we will have some more discussions about these different protocols, which is very important pagdating sa Open RAN system. Okay. All right. So let's take a look and map it sa ating mga equipment. Like for example, we have the core network, and then you have the BBU, and then you have the RRU, and then you have the antenna, right? When we map it in the OSI layer, so we have this layer 1, okay, layer 2, and layer 3 is here. Okay, so BBU is a layer 2 and layer 3 equipment, and the RRU sometimes it's most of the time it's a layer 1 equipment. No? So RF and the physical layer. So there is a functional split that we will be discussing later. What will be the different functional splits? So the main concept of that is you are splitting the protocol for each of these processes to be able to use it in the different applications, especially, for example, in the cases of 5G. Okay. So this is where you can see the different protocols. In the BBU, it's handling the RRC, the PDCP, the RLC, the MAC, and the physical layer. Okay. And the RF or the physical layer, lower physical layer is in the RRU. Okay, so this is where the breakdown of the OSI model layer and the RAN layer. So like for example, in the layer 3, which is the network layer, you can see the RRC protocol. So the RRC protocol is what we call the radio resource control. So this is used for signaling between the UE and the base station. So in terms of the control plane. So the RRC control plane protocol is contained within the radio access network layer 3. So ito yung ginagamit natin for broadcast, for paging, for connection management, mobility functions, measurement configuration, and reporting. So whenever your mobile phone, yung mga telepono nyo, when you look at your mobile phone right now, and then you're not doing anything, that means your phone is in the idle mode. Idle mode. It doesn't do anything. Once you try to browse the website, or try to make a call, or try to send an SMS, it's now on the dedicated mode. Okay, so we have two major: idle mode and the dedicated mode. Now, even in dedicated mode, once you are trying to, for example, try to do a speed test. So in the application in the application that you use, like for example, a speed test, you will just see it measures the maximum download throughput and the upload throughput. But what really happens in your user equipment is like this, especially if you are connected in a 5G network. So you can see, this is what you see in your mobile phones. You can see that, oh, I'm downloading around 500 Mbps. How cool is that? And then I'm uploading around 33 or 40 Mbps. So that's what you only see. But inside your mobile phone, when you connect a drive test tool, like for example, what I'm showing to you, this is the parameters that your phone is currently handling. Okay. So remember the protocols. So we have the RRC, the PDCP, the RLC, the MAC, and the physical layer. So in the RRC, you can see these messages. Okay, so this is the messages that is happening between your mobile phone, okay, or your cell phone going to the base station or radio access network. So they are talking to each other with this kind of messages. So we call it the layer 3 messages. Okay, so you can see if they are receiving the broadcast, the master information block, okay, and then the paging, if the system is paging you, if there's the RRC connection reconfiguration, okay, so you can see it here. But if you're using just your phone, you cannot see it, okay, you cannot see this one, okay. But if you use or you connect your phone into drive test tool, you can see the layer 3 messages, okay, and you can also see the events, what is happening. If you were handed over to another cell, or if your phone is requesting for a random access channel, or if the NR cell is going to release you, meaning bibitawan ka na nung 5G at babalik ka na sa LTE. So all of this are being captured in this kind of tool, in this sample tool. And then you can also see the layer 1 parameters, the physical parameters, physical layer parameters. So in this case, you can see the signal level, okay, the actual signal level of your 5G system. What you can see here in your phone is only the signal bar, correct? So you can see if you have 1 bar, 2 bars, 3 bars, or 5 bars, or 10 bars. But using this tool, okay, you can see the actual signal level and the actual quality of your signal, real time. Okay, you can also see what network are you camped on and what frequency are you using. Okay, what specific subcarrier spacing are you using. Okay, you can also see the PCI, the physical cell identifier. Okay, you can see the modulation your phone is currently using. Like for example, here is 64 QAM or QPSK or 16 QAM or 256 QAM if it is available. And also, since our 5G network currently in the Philippines is using what we call the NSA model, so the non-standalone mode, we are using an LTE as the anchor site, okay, anchor. So you can see also the parameters of the LTE. As you can see, the signal level of the LTE is not the same as the signal level of your 5G. Why? Because number one, the frequency is different. Your LTE here is using L2100, 2100 megahertz of band 1. However, in your 5G, you are seeing band 78, which is a 3.5 gigahertz. So in terms of the propagation, you have a different signal level. Okay, that's why you can see a different signal level measurement from the 3G, from the 5G and the LTE. And you can see also the different layers, the different throughputs in the different layers. You can see the PDCP layer, the RLC layer, the MAC, and the physical layer. Okay. Okay. So makikita natin dito yung mga iba't ibang throughput layer. So typical, mas mataas is on the PDCP layer because that is the first encounter na makukuha natin yung throughput. And then later on, there will be some encapsulation para makuha natin yung talagang data until bumababa yung ating mga throughput. Okay? So that is our layer. So now you're now aware about the RRC. The PDCP, it handles, like for example, it's a user plane protocol that provides yung mga ciphering, integrity protection, okay, and then header compression, because if you do not compress the header, it will consume a lot of the air interface. So you need to compress the header of your transmitted data, and it is being done in the PDCP layer. Now, in the RLC, there is what we call the segmentation and concatenation, the automatic repeat request, automatic request, and then duplicate detection. So the RLC decides, like for example, you have a very big data that will be transmitted, and the air interface cannot handle it. So what the RLC will do, it will segment. Okay, it will segment your data into two. So first transmission is one, second transmission is one, because we cannot transmit as a whole. So that's one of the job of the RLC, just to make it simple. In the MAC, in the medium access control layer, it is responsible for prioritizing and multiplexing of logical channel data received from the RLC layer. So this is where the carrier aggregation is happening. Okay, so if you want to combine carrier 1 and then carrier 2 to have a better throughput, it is happening in the MAC layer. Okay, now goes to the physical layer. So the physical layer provides a physical layer processing as well as the transmission and reception across the air interface. So inside the physical layer, you will have this CRC, or the cyclic redundancy checking. This is where we add bits to each transport block at the transmitter to allow yung ating mga error detection at the receiver. Okay? And then we have the channel coding, where we apply or to generate the redundancy to increase yung resilience ng ating mga radio propagation channel. So we were adding additional bits, no? Kasi kapag na-receive niya, pagka nakita niya yung bits na to, teka, dapat meron tayong dalawang zeros dito or dalawang ones dito. Bakit mali yung bits na to, no? So that is part of the channel coding. And then there is also what we call the interleaving. So this is to improve yung performance ng decoding by randomizing, no, yung mga burst of contiguous bits. So when you remember the matrix when we are doing the advanced mathematics in college, so I hope you would like to remember that. We are doing the inverse matrix, no? So parang ganun yung ginagawa sa interleaving. Yeah, so binabaligtad natin yung matrix natin. And then we have this modulation. So we apply the mapping of these different bits into the air interface resources, like for example using this OFDM in the downlink and the discrete Fourier transform in the uplink scenario, in the uplink way. Yeah. Okay. And then we have the RF conversion. So from analog to digital or digital to analog. So where we try to let it out, no, yung ating like radio frequency papunta sa antenna natin. Okay, so ito na yung RF natin. So after the modulation, pupunta yan mga amplifiers natin. Okay, so ito yung ating distribution ng mga functions of our radio equipment compared sa mga functions nila in terms of the comparison with the OSI layer and mapping it with the radio access network layer. So if you will be asked, no, sa inyong mga quiz. So the network layer, data link layer, andito yung mga. So network layer is RRC, data link layer is PDCP, RLC, and MAC, and the physical is physical and RF. But you will see later on in the different split options provided by the 3GPP, sometimes the physical layer is being split into the baseband unit and sometimes in the RU. So there is the what we call the split 7 and the split 8. So later on we will be discussing that. Okay. All right. So far we have discussed a lot. Ayan. So question ni Carl is meron nagka-transmit, nagbubuga ng signal papuntang US. Yung electromagnetic energy coming from the RRU, Carl. And then yung antenna natin, yung RF antenna natin, if it's passive antenna, it only helps us to focus the electromagnetic energy. Parang ano, meron kang flashlight, Carl. Pag may flashlight ka, yung ilaw, no, yun yung pinaka-RRU mo. Okay? And then yung RF antenna mo, yung pinaka mirror sa likod nung ano mo, nung iyong flashlight. So the RF antenna just helps you focus yung electromagnetic energy. Pero yung electromagnetic energy is emanating from the light. Okay? So it's the same goes with the radio access network.